Hello friends. In last lecture we have discussed about the what is steam, how it is defined, then some of the terminology regarding the steam formation, then types of the steam, and dryness fraction and wetness fraction. Today in this lecture we will see the different enthalpies of different phase of the water and the steam table that is most important and used widely for the boiler. So let's start from the enthalpies. The first one, that is the enthalpy of the steam. So for that we know that a non-flow energy equation in which the heat supply Q, that is the change in internal energy delta U plus work, that is PdV. So we can write it is equal to U2 minus U1 plus P V2 minus V1. And if we rearrange this equation, then it is equal to U2 plus PV2 minus U1 plus PV1. Now we know that the equation for this specific enthalpy, that H equal to U plus PV. So if we replace this H by U plus, if we replace this U plus PV by H, then the equation comes, that is Q equal to H2 minus H1. So we can say it's a delta H. So from this equation we can say that whatever heat we are supplying to the steam, that is same as change in specific enthalpy for the steam, right? Now the next, that is enthalpy of the liquid, and that is denoted by HF. You can see HF, that is also the sensible heat. Now the liquid phase that is available in this diagram, you know that from point A to point B. At point B it started to boiling. So just before point B and from point A means 0 degree Celsius to the T saturated, before just T saturated, it is available in the liquid phase. So if we measure the enthalpy of the liquid, that is denoted by HF. So for the unit mass, it is denoted by HF, and we know the enthalpy equation, that is mCp delta T. So here for the unit mass, so the m, that is equal to 1, Cp, that is specific enthalpy or specific heat of water, because here the phase is water, so specific heat of the water, and that value is 4.1868 kilojoule per kg Kelvin. That is fixed specific heat value of the water. So HF, that is equal to CPW, and delta T, that is, we know that TF at some point in this line, any point we can take, that point is TF. Okay, so at that particular point, that is the TF minus 0 degree Celsius. Okay, so again I am telling that enthalpy equation, that is mCp delta T. Here m is unit mass, so it is 1. Specific heat, that is for the water, so CPW, and delta T, that is TF minus 0 degree Celsius. TF, that is at any point where we are measuring the enthalpy of the liquid. Okay, so this is about enthalpy of the liquid. The next one, that is enthalpy of the dry saturated steam, right? Now we know that the dry saturated steam that is available at point C, right? Between B to C, that's a wet steam, okay? And particular at point C, we have the dry saturated steam. So if we see the projection over the enthalpy line, so you can see that at point C, the enthalpy value, that is the summation of HF, means here to here, that is HF, plus from here to here, that is HFG. So we can say that the Hg, that is the enthalpy of dry saturated steam, that is denoted by Hg. So Hg, that is the summation of HF plus HFG. Okay. Now if we want to measure the enthalpy of the wet steam, okay, now we know that wet steam that is available between the B and C, okay, at any point. Suppose I have taken this point, okay, and I want to measure at this point the value of enthalpy, okay. So at the here it is the summation of HFG is total from up to here, okay, and from here to here at this projection it is the x fraction of HFG. It is not the total HFG, okay. What is x? X, that is the dryness fraction that we have already seen in the last lecture, okay. So if we multiply this HFG into the dryness fraction, so at particular point how much latent heat we have supplied, that we can get, and so up to that we have to add. So it is of HF plus X into HFG, okay. The next is enthalpy of the superheated steam. So we know that superheated steam, that is after point C, right, at any point. So how it is defined? So H superheated, that is equal to, from here to here it is HF, from here to here it is HFG. So HF plus HFG plus, now from here to here, whatever point, okay. So if we want to measure the enthalpy of from after this point C for the any point, okay, we give the projection. So that enthalpy, again the equation is mc delta T, right, but we are deriving this equation for the unit mass, so m is 1. Now here the specific value of water is not coming because here it is only in a steam phase. So we have to take on the specific heat of the steam, and that value of that superheated steam, specific heat of the superheated steam at constant pressure, that is 2.0934 kilojoule per kg Kelvin. Okay, so that is again mcp delta T, and delta T, that is the value of point D where we are measuring. So it is 2 superheated minus T saturated. So specific heat multiplied by T superheated minus T saturated. So up to that point, it is the summation of this all thing. And we know that again HF plus HFG, that is HG, right? So we can replace. Here you can see that HG, that is summation of HF plus HFG. So we can replace this HF plus HFG by HG. So this equation becomes short. So this is all about the different enthalpy. Enthalpy of the liquid, enthalpy of the steam, enthalpy of dry saturated steam, waste steam, superheated steam. Okay. So this is all about the enthalpy. Okay. Now the next, that is, I just told you, that is the steam table. Okay. So from the experimental study, the various properties of the steam are tabulated at various pressure and temperature. Why it is required? Because each and every time you have to not do the practical for measuring every time the same value. Suppose I want the enthalpy entropy value at suppose 150 degrees Celsius. So experimentally it is calculated and it is specified in the steam table. So we don't have to every time calculate that value. We can directly pick up that value from the steam table. It may be pressure based or temperature based. We have two steam table. One is based on the pressure and one is based on the temperature. So both way we can identify the different value or different property of the steam. Properties are tabulated from the triple point, as you can see in the this diagram, pressure versus temperature diagram, right? The triple point, that is the point where the substance that is available in all the three phase. Okay, so that value P pressure triple point value is 0.006112 bar. So it is start from this, and temperature value of triple point, that is 0.01 degrees Celsius. Okay, and the critical point of the water, that is the last value up to which the steam table is available, that the pressure value, that is 2 to 1.2 bar. Our atmospheric pressure is 1 bar nearly. Okay, so the steam table that is available up to 2 to 1.2 bar, and for the temperature it is up to 374 degree Celsius. Okay, the value of these various quantities given in this table are for a kg of steam which is dry and saturated. So this is only for the dry and saturated. Okay. The values for unknown pressure or temperature can be calculated by linear interpolation between two consecutive values. That I will explain when we are discussing about steam table. Okay. So what are the values given in the steam table? So first column, that is absolute pressure in a bar. Okay. So this is of the based on the pressure. If the table is based on the temperature, then temperature is the first column. Here it is based on the pressure. So the first column, that is absolute pressure in a bar. Second column, that is saturated temperature in the degree Celsius. Now based on these two, we can find the dry saturated steam property. So the specific volume of the water as well as steam, because both is available in the case of the wet steam. Then specific enthalpy of the water, evaporation and steam. Okay, that is HF, HFG and Hg, that we have discussed already. And for specific entropy value is also given in the table for the water, evaporation and steam phase. Okay, so this is how the table formatted. We have the examples. So this table is for the temperature base. So here you can see that the first column, that is of temperature, those are saturated temperature. And we know that the first triple point temperature, that is 0.01. So it is start from 0.01 and last critical temperature, that is 374.14 degree Celsius. So up to that. Okay. The table is very large. For each and every uh, degree Celsius, the value is given. Okay, but for the understanding, I have sorted it. Okay. So for each and every saturated temperature, the value of pressure, that is also given in a bar, and for all that, all the properties are given of the volume, Vf, that is for the liquid, Vg for the gas, then HF, that is liquid, HF for the evaporation portion, and Hg for the steam. Same way for the specific entropy. So suppose I want to I need the properties, or I want to measure the HFG or Hg value of steam at 20 degrees Celsius. So you can see here 20 degree at 20 degrees Celsius, the value is mentioned here. Okay, so this all data from where it is come? It is come from experiments. Now the point earlier we have discussed, that is the value come we have to calculate by interpolation. Why? Because suppose from 20 degrees Celsius it is now 50 degrees Celsius, and in between, suppose we want the value, then we have to go for the interpolation. Suppose we want to measure the value at 40 degrees Celsius, then we have to do the interpolation between this, and we can get the value. So this table is based on the temperature. Now next, that is based on the pressure. So here you can see that the first column, that is of pressure, and the triple point pressure value is 0.02 and critical value is 2 to 1.2. So the table, the stream table is available between these two values. Okay. The next, that is specific temperature, superheated temperature value in the degree Celsius. Okay. So pressure at any pressure in the bar, you can find the property, these all properties of the steam. Okay, so this is all about the steam table. Okay, and this all property, again I am telling you, this all property have determined experimentally at various pressure and tabulated here. Okay, you have not the problems in your syllabus, otherwise you can calculate this um, with the use of this table. Okay, so now this is the end of the chapter 2. Okay, thank you.